All right, so this is take 4 of making this video on graphing inequalities. Hopefully we can get through it this time, all right? So this video is going to be a shorter one because it actually applies a lot of the stuff that we've already learned to this new situation. We're basically going to be graphing lines and then using inequality symbols to determine what is part of our solution set, okay? So graphing inequalities is what we're working with today. Alright, so graphing inequalities is exactly the same as graphing linear equations, alright? So, one thing to notice here. If I had y equals 2x plus 4 for this graph, rather than less than or equal to, I could very easily still draw this line with the equation, alright? So my y-intercept is 4. I go up 2 over 1, and I have my line, okay? So my line is 2x plus 4 here, okay? So that is the same. You still graph the line as you normally would. The only difference with these now is once you graph the line, you have to figure out what to do with the inequality symbol, okay? So here's the thing to note. A solid line is used when the inequality is equal to the equation itself. What do I mean by that? I mean that if you have a greater than or equal to or a less than or equal to, when you draw your line, it's going to be a solid line. Alright? However, if you have just greater than or less than, you're going to draw a dotted line. That dotted line indicates the border of the solution set for your inequality, but it also indicates that it is not part of your solution set. So that's what you're doing when you're graphing inequalities, is you have to pay attention to the symbol and graph the line in spite of that. Then you have to determine how to shade these particular regions. So how do you shade these regions? We're going to show that right now. Alright, so determining the shaded region, you use the test point 0, 0. Okay, what is 0, 0? 0, 0 is your origin. Okay? So, here's what we're trying to figure out here. We're trying to determine if this point 0, 0 is part of the solution set. And if we determine that it is, we'd shade the region that 0, 0 is in. As you can tell by this graph, 0, 0 is not part of the solution. But the way I would determine that for sure is I would substitute my x and y coordinates, that's being 0 and 0, into my inequality, okay? So let's do that real quick. Y equals 0, greater than 2 times x, which is also equal to 0, plus 4. So if I were to solve this, 0 is greater than 4. Is 0 greater than 4? No, it is not. So that means 0, 0 is not part of our solution set. And once we conclude that, we can shade in our region. Okay? It's that simple. So you just graph the line, determine if it's a straight or dotted line, and then find your shaded area by substituting 0, 0 into your equation. Okay? Pretty straightforward. Alright, so let's do this one real quick. Graph x minus y is greater than or equal to negative 2. Okay, so when we're doing this, we want to convert. First of all, you notice that this is in standard form. To make it easier on us, we want to convert it to slope-intercept form. Remember, slope-intercept form is y equals mx plus b. Okay? So that means what we're going to do first is we're going to subtract x from both sides. We're solving for y. So negative y is greater than or equal to negative x minus 2. Alright? Alright. So, now we know we have a negative y here. We cannot have that for slope-intercept form, so we're going to multiply both sides by negative 1. And that will give us y is less than or equal to x plus 2. Okay. So, we have our, remember, if we're multiplying by -1, we flip the inequality symbol. So that's what we did. We flipped the inequality symbol. So let's draw our line. So our y-intercept, first of all, is 2. So we start off on our y-axis, 2 units above the x-axis. And then we determine our slope. Our slope is 1, because there's a 1 in front of the x. Remember, our slope is mx, so 1x. So we go up 1 and over 1, and then we draw our line. That's a pretty bad drawing of a line, but it serves our purposes. So 1x plus 2, this is our line. And remember, it's equal to, so that makes it easy for us to determine that it's a solid line rather than a dotted line. So we checked that. That's good. If this was just less than, it'd be dotted. All right. So now we need to determine the shaded region. To determine the shaded region, remember, we use our test point being the origin, 0, 0. And how do we use our origin? We substitute in to our found equation. Okay? So 0 is less than or equal to 0 plus 2. Okay? 0 is less than or equal to 2, which in fact it is. So we can determine that 0, 0, or our origin, is part of our solution set, and that gives us enough reason to believe that this is our shaded region. So first step, determine where your line's at. Second step, determine how the inequality symbol influences your line. And then final step, use your test point to determine your region. All right? It's just 3 simple steps to remember. All right, try this one on your own super quick. All right, so 3x minus 4y is less than -8. All right, first off, again, it's in standard form. So to make it easier on all of us, we are going to convert this to slope-intercept form. So what I need to do first is solve for y, subtract 3x from both sides. So that'll give me -4y is less than -3x minus 8. Okay? -3x minus 8. Now I cannot have -4y in slope-intercept form, so I have to divide everything by -4. And I'm dividing by a negative, so that means I flip my inequality symbol. So y equals 3 over 4, because 2 negatives make a positive, x plus 2. So there's my slope-intercept form. All right, so let's graph it. My y-intercept is 2. So start 2 units above the x-axis. And then my slope is 3 over 4. So I have to go up 3. 1, 2, 3. Over 4. Done. All right. Now, take a look at my inequality symbol. My inequality symbol is a greater than, which means it's not equal to, so I have to use a dotted line on my graph, indicating that it is not part of my solution, but it is the edge of it. I did the best I could with that. All right, so now I have my line. Now I need to determine my shaded region. So I'm going to use my origin again to see if it is part of the solution. If you have a line that's crossing through the origin, you can use a different point. So you could use, say, 2, -2, and you'd still be able to determine if this side is part of your solution set. 0, 0 is just a lot easier to work with than any of these other numbers. Okay? So 0, 0, 0 is greater than 3 over 4 times 0, substituting in now, plus 2. 0 is greater than 2. But is 0 greater than 2? It is not. So that means 0, 0 isn't part of our solution, which means the other side is our shaded region. Okay? So it just comes down to determining your line and your shaded region. Alright, this is where it gets a little more interesting. We're applying absolute value equations to our inequality situation. So now this is an absolute value inequality, which we've also worked with. So we're going to graph this absolute value inequality. Alright, if you remember, the fast way to graph these, you have x, absolute value of x minus h plus k here. So we know that our vertex is going to be in a particular location. So -2 inside our absolute value means that we move 2 units in the positive direction on the x-axis. And then for our y-intercept, which is k, we follow and move 1 unit up. So our vertex is here, and then we draw our graph. Remember, because it always ends up being a V, increasing x and y by 1 every time. Okay? Alright. Now, you may have already noticed I made a little bit of a mistake. This should be a dotted line. So let's fix that real quick. Oops. Let's make a little quick fix there. Let's draw our dotted line. And I am really not good at drawing. If you're not good at drawing, you don't need an exact, but it's just close. Just close from so I can see it. Alright. Now, we have our first thing done, where we drew our line. We've determined it's a dotted line. Now we have to use the origin to determine what our shaded region is. Okay? So we're going to substitute in. 0 is greater than absolute value of 0 minus 2 plus 1. So that means 0 is greater than 3. Is 0 greater than 3? It obviously is not. So the origin is not part of our solution set, which means we shade everything within the V. That is how you determine absolute value inequalities in any given situation. Alright. Again, you are always able to email me if you have any questions in regards to what we discussed in this short video, and just make sure to take a look on Google Classroom for the homework assignment. Alright? Alright. I will see you all tomorrow.